This is a GCSE AQA chemistry question. It's from a trilogy paper 2019 and it's also foundation level question. And it includes bonding and a little bit on chemical calculations, but very, very simple. I'm going to put all of the information up so that you can have a go at the question in full and then review later. So pause as you go. So here is part A and B, part C, part D, part E, and finally part F. So for part A, we have got the state symbol of oxygen at room temperature. So you need to know that oxygen is a gas, and you need to know the state symbol for gas is a G in brackets. And then we've got percentage by mass of calcium in calcium carbonate. This circle is divided into 10, and calcium takes up 4 of those divisions. So the correct answer is 40%. For part C, we've got to work out an average, a mean. So the mean mass of solid after heating, we've got 3 figures to use. So we're going to take each of them. We're going to divide by 3 and we get to the answer 3.94 grams. The final mark here is for making sure it's to 3 significant figures, because it will be to significantly more than that when you do it on your calculator. On to part D, and we've got a covalent bond structure diagram. Now, oxygen is in group 6, which means it has 6 electrons in its outer shell, which means it needs to gain 2, which means it will form 2 covalent bonds. It's already formed 1 covalent bond here, so we're going to form one in the other shared area. You can also see hydrogen puts its 1 electron in so it can share, so it now has 2. Both of these hydrogens now have a full outer shell. Oxygen is in group 6, so 6 electrons in the outer shell. It's used 2 of them, so that means 4 remaining, and we're now done. On to part E. There are covalent bonds between the atoms of oxygen in an oxygen molecule. It's worth pointing out here that oxygen exists as a diatomic molecule, O2. And then finally, we've got the comparison of the size of oxygen and sulfur, and we want to now compare their boiling points. The boiling point of sulfur is higher than the boiling point of oxygen. That will always be true in simple covalent or molecular covalent substances. If the molecule is bigger, the boiling point is higher. And the reason for that is that the intermolecular forces, the forces between the molecules in sulfur, are stronger than they are in oxygen. They're stronger in bigger molecules or bigger atoms than they are in smaller molecules or atoms. And that takes us to the end of the question.